Let's close this section out with one more example that we'll run through from the top. So here's the question. Is poverty correlated with diabetes in Michigan? Let's take a look at the data. These data in this Excel spreadsheet provide us with the poverty rate and the diabetes rate from most of the counties in Michigan. Not all of them had complete data, but these counties all had data, and we can scroll down and we can see going all the way down to Wexford in row 61 that there's about 60 counties here. So let's start by making a scatter plot. And I'm not going to worry too much about labels. I just want to take a look at what it looks like. Right? So let's create a scatter plot. So what we have is the diabetes rate is on the vertical axis and the poverty rate is on the horizontal. And these are in percentages. So 15 here means 0.15 or 15%, whereas 8 here means 8%. Right? 8% of the county has diabetes, 15% of the county is below the poverty level. Doesn't look very promising. Take a pause for a moment and try and guess what you think the correlation coefficient will be. Hopefully you've made a guess. Let's actually run the regression and see what we find. So to review, to run the regression, I'm going to put my regression results right here. So remember, we go to data. You should have downloaded the tool pack. So we select data analysis. We select regression. In here, input Y range, clicking on the arrow allows you to highlight, and I'm going to highlight the diabetes range. We want to know if poverty predicts diabetes. So that diabetes data are in the Y range. For the X range, we want to know if the poverty rates predict those diabetes rates or if there's any association. Get those in there. And now I just want to make sure I can dictate where the regression goes. I'm happy with it right there. And now we hit OK and run the regression. So first, let's take a look. Our X variable is 0.08. That means our slope is about 0.08, pretty small, with an intercept of 6.5 or 6.6, which would tell us that in the absence of any poverty, we would expect a 6.6% diabetes rate. But how strong is this correlation, right? So this correlation is based on these numbers. I will highlight them in yellow as before. This is the equation for the line of best fit. But how much can we rely on that? If I highlight these in green, these are the numbers we might care about. The correlation coefficient is about 0.155. That's certainly not nearly as strong as the 0.97 we had for the salary data. In fact, it's quite weak, quite close to 0. And the R squared tells us that the variation in the poverty rate explains about 2% of the variation in the diabetes rate. That seems pretty weak. Let's take one more look at one more measure, which is the confidence interval, our 95% confidence interval. And for this, we're just going to look at the slope. I'll highlight both of these in blue. And take a look at those numbers. The lower number is negative, the upper number is positive, so that means it's not unreasonable for the slope to be approximately 0, which would mean the poverty rate would have no impact on the diabetes rate. So this is what it might look like if you have weak to no association between two variables. Now, why would we think there might be a relationship? Well, there is a relationship between obesity and diabetes, and there's a slight relationship between poverty and obesity, so we might think that poverty might influence diabetes through this common variable, obesity. But according to this data, we have very weak evidence that there's any association at all. In our final section, we're going to take a quick look at a few other models, and then we're going to summarize what we've done in the course before moving on to our project.